Have you ever wondered why some people spend hours walking every week, yet see only modest improvements in their weight, blood sugar, and overall fitness, while others seem to achieve dramatic results with far less exercise? What if I told you that new research suggests that, minute for minute, vigorous exercise may be anywhere from 4 to 10 times more powerful than moderate exercise for reducing the risk of heart disease, type 2 diabetes, metabolic dysfunction, and even premature death? Now, before you assume this means you need to start doing exhausting workouts every day, stay with me, because that's not what the science is saying. Here's what makes this topic so important. Most people are dealing with symptoms, fatigue, stubborn belly fat, poor blood sugar control, low energy, declining fitness, and accelerated aging. But these symptoms often share a common root cause: declining metabolic health. And one of the fastest ways to influence metabolism is through movement. The question is not simply whether you exercise. The question is, what kind of signal are you sending to your cells? Let me explain this with a simple analogy. Imagine your metabolism is like a factory. Moderate exercise is similar to running the factory at a steady pace. That's helpful. But vigorous exercise is like flipping on an emergency optimization system. Suddenly, more energy is produced, more fat is burned, more mitochondria are built, and your body becomes dramatically more efficient. Recent studies using wearable activity trackers have shown that even brief periods of vigorous activity can produce disproportionately large health benefits compared with moderate intensity exercise. Some findings suggest that just a few minutes per day of vigorous movement may significantly lower the risk of cardiovascular disease, cancer, and all-cause mortality. So in today's video, we're going to uncover what's really happening inside your body. We'll explore why intensity matters, how vigorous exercise changes insulin sensitivity, fat burning, mitochondria, hormones, cardiovascular fitness, and longevity, and most importantly, how you can apply these findings safely and practically. And if you're interested in evidence-based strategies to improve your health naturally, consider subscribing. I post content like this every day to help you understand the science and turn it into real-world results. One of the biggest misunderstandings in fitness is the belief that all exercise creates the same benefits as long as you burn enough calories. But that's not how human physiology works. Here's what's really going on inside your body. Your body doesn't simply count calories, it responds to signals. Every time you exercise, you're sending information to your muscles, your liver, your heart, your brain, and even your genes. The intensity of that exercise determines how strong that signal becomes. Let me explain this with a simple analogy. Imagine you're trying to renovate a house. If a single worker shows up and slowly paints a wall, the house changes very little. That's similar to low or moderate intensity activity. Helpful, but the body doesn't feel a strong need to adapt. Now imagine a large construction crew arrives and begins rebuilding the entire structure. Suddenly the house must upgrade quickly. That's what vigorous exercise does. When exercise intensity rises, your body enters a state of controlled metabolic stress. This isn't harmful stress. It's a powerful signal that tells the body it must become stronger, more efficient, and more resilient. Researchers call this adaptation. The higher the demand placed on the body within reasonable limits, the greater the adaptation that follows. This is one reason studies continue to show that vigorous physical activity delivers substantially greater health benefits per minute than moderate activity. The body perceives a stronger challenge and responds with stronger improvements in fitness, metabolic flexibility, cardiovascular function, and energy production. One of the most important concepts here is metabolic flexibility. Metabolic flexibility is your body's ability to switch efficiently between burning glucose and burning stored fat. Many people today have become metabolically inflexible. They rely heavily on glucose, struggle to access body fat for fuel, experience energy crashes, frequent hunger, and difficulty losing weight. Vigorous exercise directly challenges this system. During higher intensity activity, muscle cells rapidly consume fuel. Glycogen stores are depleted faster. Energy demand rises sharply. After the workout, the body works hard to restore balance, improving its ability to manage both glucose and fat. This process creates a metabolic upgrade that often exceeds what we see from longer periods of moderate exercise. Another major difference involves signaling molecules called myokines. Think of myokines as messenger proteins released by your muscles during exercise. When muscles contract intensely, they release larger amounts of these beneficial compounds. These signals communicate with the liver, pancreas, fat tissue, blood vessels, and even the brain. The result? Better insulin sensitivity, reduced inflammation, improved blood vessel function, enhanced fat metabolism, and stronger protection against age-related disease. What's fascinating is that many of these benefits continue long after the workout ends. The exercise session may only last a few minutes, but the physiological improvements can continue for hours or even days. This helps explain why short bursts of vigorous movement often outperform much longer workouts when researchers compare health outcomes. Now, this doesn't mean everyone should immediately start doing all-out sprints. The goal is strategic intensity. For most people, a good starting point is introducing 1 or 2 short, vigorous intervals into an existing workout. For example, during a walk, spend 30 seconds climbing a hill quickly. On a stationary bike, pedal hard for 20-30 seconds. While swimming, increase pace briefly before returning to recovery speed. These short efforts create a disproportionately powerful signal without requiring hours in the gym. And that's the first major lesson from the research. The body doesn't just respond to movement, it responds to challenge. And when that challenge is appropriate and intentional, the metabolic rewards can be far greater than most people realize. If this is helpful so far, consider subscribing. Understanding how your body actually works is one of the most powerful tools you can have for improving energy, fat loss, and long-term health naturally. If there is one reason vigorous exercise deserves so much attention in metabolic health, it's this. Few interventions improve insulin sensitivity as quickly and as powerfully. And if you want to understand fat loss, energy production, healthy aging, and disease prevention, you have to understand insulin because insulin sits at the center of the metabolic conversation. Here's what's really going on inside your body. Every time you eat carbohydrates or even protein to some degree, your pancreas releases insulin. Insulin's job is simple: move nutrients from the bloodstream into cells. In a healthy body, this process works efficiently. But over time, especially with frequent eating, excess sugar intake, poor sleep, chronic stress, and inactivity, cells begin responding less effectively to insulin. This is called insulin resistance. Think of insulin as a key and your cells as doors. In the beginning, one key easily opens the door. But after years of metabolic overload, the lock becomes rusty. Now the body needs more and more insulin just to produce the same effect. This is where many problems begin. Higher insulin levels make it harder to burn stored body fat. The liver starts producing more fat, blood sugar becomes unstable, inflammation increases, energy declines, and the risk of type 2 diabetes, fatty liver disease, cardiovascular disease, and cognitive decline rises significantly. Now here's where vigorous exercise becomes remarkably powerful. During high-intensity activity, working muscles demand enormous amounts of fuel. The body cannot wait for insulin to do all the work. Instead, muscle cells activate alternative pathways that rapidly pull glucose out of the bloodstream. It's almost like opening additional emergency entrances into the cell. This means blood sugar can be cleared more efficiently even with lower insulin levels. And over time, those cells become much more responsive to insulin itself. Researchers have repeatedly observed that high-intensity interval training can improve insulin sensitivity in surprisingly short periods, sometimes within just a few weeks. What's especially interesting is that these improvements often occur even before significant weight loss happens. That tells us something important. The body is becoming metabolically healthier first. The weight loss often follows. This is a critical distinction because many people focus exclusively on the scale, but the real goal should be restoring metabolic function. When insulin sensitivity improves, your body gains easier access to stored fat. Energy production becomes more stable, cravings often decrease, blood sugar fluctuations become less severe, and fat accumulation around the abdomen and liver becomes easier to reverse. Let's talk about the liver for a moment. In functional medicine, we often view fatty liver as one of the earliest warning signs of metabolic dysfunction. The liver acts like a central processing center for nutrients. When insulin remains elevated for years, the liver starts converting excess glucose into fat. Eventually, fat accumulates inside liver cells. This contributes to insulin resistance throughout the entire body. Vigorous exercise helps interrupt this cycle. As muscles increase fuel demand, glucose is redirected toward energy production instead of long-term storage. Over time, liver fat can decline, insulin sensitivity can improve, and overall metabolic flexibility can be restored. Now, does this mean moderate exercise has no value? Not at all. Walking after meals remains one of the most effective blood sugar lowering habits available. Daily movement is foundational, but the emerging evidence suggests that adding even small amounts of vigorous activity creates an entirely different physiological response. So, what does this look like in practice? A simple beginner protocol might include 3 times per week. Warm up for 5 minutes. Perform 20 seconds of hard effort. Recover for 90 seconds. Repeat 4-6 times. Finish with a cool down. The entire session may take less than 15 minutes, yet the metabolic effects can last much longer. The key takeaway is this: insulin resistance doesn't improve simply because calories were burned. It improves because cells receive a powerful signal to become more efficient. And vigorous exercise may be one of the strongest natural signals we currently know. If this is helpful so far, consider subscribing. Every week, we break down the science of metabolism, hormones, nutrition, and healthy aging into practical strategies you can actually use. Now let's move deeper into the cell. because one of the most overlooked reasons vigorous exercise produces such dramatic health benefits has nothing to do with calories, body weight, or even muscle. It has to do with your mitochondria. And if you've been struggling with fatigue, slow metabolism, poor recovery, brain fog, or declining energy as you age, this may be one of the most important concepts you'll ever understand. Here's what's really going on inside your body. Mitochondria are often called the power plants of the cell. Their job is to convert nutrients and oxygen into usable energy, known as ATP. Every heartbeat, every breath, every thought, every muscle contraction depends on ATP. Without healthy mitochondria, nothing works optimally. Now here's the problem. As we age, and especially when we spend years overeating, sitting too much, sleeping poorly, or living with chronic metabolic dysfunction, mitochondrial performance begins to decline. The body may still have enough energy to survive, but it no longer has the energy to thrive. Many people describe this as, I don't feel sick, but I don't feel great either. They wake up tired, need caffeine to function, experience afternoon crashes, struggle with exercise recovery, and notice that their physical capacity seems lower than it was 10 years ago. In many cases, declining mitochondrial function is part of the story. Let me explain this with a simple analogy. Imagine a city powered by thousands of small electrical plants. If those plants are efficient and abundant, the city runs smoothly. Traffic flows, businesses operate, lights stay on. But if half the power plants become old, damaged, or inefficient, the city starts experiencing shortages. Everything slows down. That's essentially what happens when mitochondrial function deteriorates. Now, here's where vigorous exercise becomes incredibly powerful. When you perform short periods of intense activity, your muscles suddenly require massive amounts of energy. The demand rises so quickly that the body interprets it as a signal. We need more power-generating capacity. In response, a process called mitochondrial biogenesis is activated. This is the creation of new mitochondria. Think about that for a moment. Your body doesn't just use mitochondria during exercise, it can actually build more of them afterward. That's one reason researchers often describe exercise as a form of cellular medicine. You're literally sending instructions that tell the body to upgrade its energy-producing machinery. What's fascinating is that higher intensity exercise appears to stimulate these adaptations far more efficiently than lower intensity activity. When scientists examine muscle tissue after interval-based training, they often find significant improvements in mitochondrial density, mitochondrial function, and aerobic capacity, even when total exercise time is relatively short. This helps explain why many people report feeling more energetic after implementing properly structured, vigorous exercise. The workout itself may feel challenging, but the adaptation afterward often results in greater daily energy. And there's another important benefit. Healthier mitochondria improve metabolic flexibility. Remember what we discussed earlier. A metabolically flexible body can switch between glucose and fat efficiently. Mitochondria are central to this process because they're where much of that fuel gets burned. When mitochondria become stronger and more numerous, fat oxidation improves. Energy production becomes more efficient. And the body becomes better equipped to access stored energy instead of constantly demanding quick carbohydrates. This is one reason people frequently notice fewer cravings and more stable energy after several weeks of interval training. They're not just burning calories, they're upgrading their cellular engines. Now let's talk practical application. You don't need elite athlete workouts to stimulate mitochondrial growth. A simple protocol might look like this: 5-minute warm-up, 30 seconds of vigorous effort, 90 seconds of recovery, repeat 5 to 8 rounds. Perform 2-3 times per week. Walking, cycling, rowing, swimming, stair climbing, or even fast hill walking can work. The specific exercise matters far less than the metabolic challenge. Recovery is equally important. Mitochondria are built during recovery, not during the workout itself. This means prioritizing 7-9 hours of quality sleep, consuming adequate protein, managing chronic stress, avoiding excessive training volume. More is not always better. Better adaptation is better. And that's the third major lesson from the research. Vigorous exercise isn't simply training your muscles, it's training your cellular energy system. The stronger your mitochondria become, the more energy your body can produce, the better your metabolism functions, and the greater your resilience against many of the diseases associated with aging. If this is helpful so far, consider subscribing. My goal is to help you understand the root causes behind health, energy, fat loss, and longevity, so you can work with your biology instead of constantly fighting against it. Now let's talk about the topic that gets the most attention whenever exercise is discussed: fat loss. And what I'm about to explain may completely change the way you think about burning fat, because one of the biggest myths in the fitness world is that the best workout is the one that burns the most calories. At first glance, that sounds logical. If fat loss is about calories, then the workout that burns the most calories should always produce the best results. But human physiology is far more sophisticated than a simple calorie calculator. Your body is not a bank account, it's a hormone driven biological system. And hormones determine whether stored fat is released, burned, or stored. Here's what's really going on inside your body. When most people exercise at a moderate pace for extended periods, they certainly burn energy. There's value in that. But vigorous exercise creates something different. It triggers a cascade of metabolic and hormonal adaptations that continue influencing fat burning long after the workout ends. This phenomenon is often called excess post-exercise oxygen consumption, or EPOC. You can think of it as an afterburn effect. Let me explain this with a simple analogy. Imagine you have a fireplace. Moderate exercise is like adding a small log that burns steadily for a while. Vigorous exercise is like adding several larger logs and increasing airflow. The fire continues producing heat even after you've stopped actively feeding it. That's essentially what happens metabolically. Following intense exercise, the body must restore glycogen stores, repair muscle tissue, normalize hormone levels, replenish cellular energy systems, clear metabolic byproducts, adapt to the stress that was created. All of these processes require energy, which means calorie expenditure remains elevated even after the workout ends. But the story gets even more interesting. The biggest fat loss advantage of vigorous exercise may not be calorie burn at all. It may be what happens to insulin. Remember from the previous section that elevated insulin makes fat burning more difficult. When insulin levels remain chronically high, your body receives a signal to store energy. When insulin sensitivity improves, your body gains easier access to stored fat. This is why two people can consume similar calories yet experience dramatically different fat loss outcomes. The more insulin-sensitive individual often has a much easier time mobilizing stored fat. Vigorous exercise is one of the most effective natural ways to improve this process. And there's another factor that many people overlook: muscle preservation. One of the biggest mistakes in weight loss is focusing solely on scale weight. The goal is not simply to become lighter. The goal is to improve body composition. You want less fat and more metabolically active muscle. Why? Because muscle acts like a metabolic engine. The more healthy muscle you maintain, the better your glucose control, insulin sensitivity, strength, mobility, and long-term metabolic health. Higher intensity exercise sends a stronger signal for muscle preservation and adaptation compared with endless low-intensity activity. This becomes especially important after age 40, when age-related muscle loss, known as sarcopenia, begins accelerating. Many people lose muscle and gain fat simultaneously without realizing it. Their weight may stay similar, but their metabolic health worsens. Strategically incorporating vigorous exercise helps counter this trend. Now, I want to emphasize something important. This does not mean more intensity is always better. Excessive high-intensity training without proper recovery can elevate stress hormones, impair recovery, and increase injury risk. The goal is not exhaustion. The goal is adaptation. Think of exercise as medicine. The correct dose creates improvement. Too little has limited effect. Too much can create problems. For most people, a sustainable approach looks something like this: daily walking for baseline metabolic health, strength training 2-4 times per week, short vigorous intervals 2-3 times per week, consistent sleep and recovery. This combination often produces far better results than relying on long-duration cardio alone. And perhaps the most important takeaway is this: fat loss is not simply about burning calories. It's about creating a body that is biologically capable of accessing and using stored fat efficiently. When insulin sensitivity improves, mitochondria become stronger, muscle mass is preserved, and metabolic flexibility increases, fat loss becomes a natural consequence of improved physiology. That's why vigorous exercise can be so powerful. It doesn't just burn energy, it changes the system that controls energy. If this is helpful so far, consider subscribing. Every day, we explore the science of metabolism, nutrition, hormones, and healthy aging so you can make informed decisions that produce lasting results. If I could measure only one fitness marker to estimate how well someone is likely to age, there's a strong chance I would choose VO2 max. Most people have never heard of it. Yet many longevity researchers consider it one of the most powerful predictors of future health, functional independence, and even mortality risk. In simple terms, VO2 max measures how much oxygen your body can take in, transport, and use during intense activity. Think of it as a report card for your entire cardiovascular and metabolic system. It reflects how well your lungs absorb oxygen, how effectively your heart pumps blood, how efficiently your blood vessels deliver nutrients, and how capable your muscles are at using that oxygen to create energy. In other words, VO2 max doesn't measure just one organ. It measures how well the entire system works together. Let me explain this with a simple analogy. Imagine your body as a city. Oxygen is the fuel needed to keep every building operating. Your lungs are the fuel import station. Your heart is the delivery truck fleet. Your blood vessels are the road network. And your mitochondria are the factories that use the fuel. If any part of that system becomes inefficient, the entire city slows down. A higher VO2 max means the city can handle larger demands without strain. A lower VO2 max means even small tasks require more effort. That's why people with poor cardiovascular fitness often feel exhausted climbing stairs, carrying groceries, or performing everyday activities. Their reserve capacity is limited. Now, here's where vigorous exercise becomes so important. Research consistently shows that higher intensity training is one of the most effective ways to improve VO2 max. Why? Because the body adapts specifically to the demands placed upon it. When you briefly push your cardiovascular system close to its current capacity, the body receives a powerful message. We need to upgrade. The heart becomes stronger, stroke volume increases, meaning more blood is pumped with each heartbeat. Blood vessels become more responsive. Muscles develop greater oxygen extraction capacity. And mitochondria become more efficient at producing energy. Over time, your body can accomplish more work with less effort. This is one reason vigorous exercise often feels difficult initially, but makes everyday life feel easier later. You are increasing your physiological reserve, and that reserve becomes critically important as you age. One of the greatest threats to healthy aging is not simply disease, it's loss of capacity, the inability to move freely, the inability to recover from illness, the inability to remain physically independent. A person with higher cardiovascular fitness enters older age with a larger buffer against these challenges. Think of it like having money in a savings account. When unexpected expenses arrive, you can handle them. Similarly, when illness, injury, stress, or aging occurs, a higher VO2 max provides physiological reserves that help you maintain function. This is why researchers often find that individuals in the highest fitness categories have dramatically lower risks of cardiovascular disease, metabolic disease, and premature death compared with those in the lowest fitness categories. The benefits extend far beyond athletics. We're talking about quality of life, cognitive function, mobility, independence, and longevity. So how can you improve VO2 max safely? You don't need to train like an elite athlete. A practical approach is to include intervals where you reach approximately 80–90% of your maximum effort. For example, warm up for 5 minutes, exercise hard for 1 minute, recover for 2 minutes, repeat 4–6 times. Cool down afterward. You should be breathing heavily but still able to recover between intervals. The goal is challenge, not punishment. And remember, adaptation occurs when effort is paired with recovery. Prioritize 7–9 hours of sleep, adequate protein intake, hydration, and electrolytes. At least one full recovery day between hard sessions. The most effective exercise program is the one you can sustain for years, not weeks. And that's the fifth major lesson from the research. Vigorous exercise doesn't just help you live longer, it helps preserve the physical capacity that makes those extra years enjoyable. Because longevity is not simply about adding years to life, it's about adding life to those years. If this is helpful so far, consider subscribing. I post evidence-based content every day to help you improve your metabolism, energy, fitness, and long-term health naturally.